Get ready, everybody, because we're diving headfirst into the world of Earth observation. But we're not talking about those grainy satellite pictures from science textbooks.
Not at all.
We're talking tech so advanced, it's practically a live HD feed of our planet.
It's incredible the level of detail we can get now. It's amazing.
Seriously, so no more blurry images. We're talking crystal clear.
Crystal clear. And it's not just about pretty pictures.
Right.
This tech, it's giving us this, totally new understanding of our planet.
Okay, so forget your grandpa's weather satellite. We are in the future. How much data are we even talking about these days?
Okay, so picture this. By 2032, all those Earth observation satellites, they're going to be spitting out something like 2 exabytes of data each year.
2 exabytes.
That's way more Netflix than anyone could ever watch, times 1,000.
Times 1,000. I don't even know what I would do with that much data.
It's a lot.
Okay. Before we get lost in the exabytes, how did we even get here? Didn't this whole Earth observation thing start with Landsat? Wasn't that back in the 70s?
Yeah, Landsat was a pioneer, it showed us we could actually look down on Earth and learn something. But what we've got going on now, it's like night and day.
Okay, so what's changed?
Everything. We're talking companies like Albedo. They're launching satellites, right? And these satellites can take pictures so sharp, it's like you can see individual trees.
Whoa, hold on. Individual trees from space?
Yeah, from space.
Yeah.
Tracking entire forests. We can even spot illegal fishing boats.
That's wild. So are we talking new satellites, new cameras? What's driving this leap?
It's a whole bunch of things coming together.
Yeah.
For one, the cameras on these new satellites, they're just light years ahead.
Okay, so the cameras are better.
Makes way better. We've got these companies like Simera Sense, and they're basically building cameras just for this.
Just for Earth observation.
Yeah. Pair those cameras with all the sensor tech we have now. Boom. Way more data. Subtle changes in, vegetation, how glaciers move. We can see it all.
Wow, that's incredible. It's like the resolution on my TV, but for the entire planet.
Right.
So it's not just about taking sharper images, it's the quality and the type of data, right?
You got it.
What else is pushing Earth observation forward?
Well, NASA's always up to something, right?
Yeah.
They've got this mission, Landsat Next. It's launching in 2030. And get this, it's going to use something called superspectral imaging. You ever hear of multispectral imaging?
Yeah. Isn't that how we get those rainbow-colored infrared images?
That's the one.
It's cool.
Right? But get this, superspectral imaging, it's like multispectral on steroids.
And steroids!
We're talking capturing hundreds of wavelengths, not just a handful. It's like going from an X-ray to an MRI of the entire planet.
Okay, so we're getting a lot more information.
A lot.
But all this data, it's overwhelming. How are scientists supposed to actually make sense of all this information?
That's the thing, right? So traditionally, analyzing all that data, it took forever. We're talking weeks, sometimes even months, just to go through satellite images.
Weeks to get a clear picture. That doesn't sound very useful when we need information quickly.
Exactly. Not helpful. But that's where AI comes in and changes everything.
AI, so artificial intelligence.
Yeah, AI, and specifically machine learning. We're talking about processing this information at speeds we could only, dream about before.
Okay, so faster processing times. How much faster are we talking?
Instead of weeks to understand data, now we're talking hours, sometimes minutes. And we can get actual insights from this data. Remember Hurricane Ian?
Yeah.
Experts used AI to figure out the damage to buildings. It was critical to getting help where it was needed.
So AI is helping us respond faster to disasters.
Exactly. And get this, Microsoft teamed up with Planet, the big Earth observation company. They were looking at Hurricane Beryl, and they were using AI to assess damage, but there was a problem.
What was the problem? Clouds.
Clouds. They had all these pictures, but some were covered in clouds. And guess what? Even with that, they still managed to identify almost 900 damaged buildings that we probably would have missed before.
That's amazing. They could see through the clouds with AI.
Not exactly see-through, but AI helped them piece together the missing information.
That's really cool. So it's not just about getting the data faster, but connecting the dots, seeing the patterns we might miss otherwise.
You got it. And you want to know what's even cooler?
What's that?
What if, instead of sending all that data back to Earth, we could just process it up in space?
Process it in space. How?
That's the idea behind satellite edge computing.
Yeah.
It's like putting a mini data center right there on the satellite.
Hold on. A data center in space. A data center dot in space.
I know, right? It sounds crazy. But it's actually becoming a reality. We're talking about a mini data center right there on the satellite.
But why? Why put a data center in space? It seems, expensive.
Totally get it.
Yeah.
But think about it. When you have a data center in space, you eliminate the whole sending data back and forth thing.
So speed is the main thing.
Speed is huge, especially in those emergency situations, right? Like, imagine a wildfire. Those minutes we save, they could be the difference between, well, everything.
So firefighters could get real-time updates on how a fire is spreading, or like we could see flood damage as it's happening?
Exactly. That's the power of edge computing.
Okay, that's incredible.
And there's this company, SkyServe. They're doing amazing stuff. They actually did this demonstration, Mission Matterhorn. They were using edge computing on a satellite. And get this, they were doing vegetation classification.
Vegetation classification.
Yeah, like they could tell what kind of plants were where, all in real time right from the satellite. They didn't have to send anything back to Earth.
That's really cool. So we've talked about these big advancements, big players. What about everyone else? Are smaller companies getting in on this?
Absolutely. In fact, it's one of the most exciting things happening. We're talking smaller, more affordable satellites. It's not just governments and big corporations anymore.
That's amazing. So more people have access now.
Exactly. More access means more innovation, new perspectives. Like, take Canada's WildfireSat. It's this dedicated wildfire monitoring satellite. And they're using this amazing infrared tech. It's smaller, more efficient. It doesn't need to be kept super cold like the old ones.
Okay, so we've got these smaller satellites, but we also have those mega satellites. It's like things are going in two opposite directions at the same time.
You're right. It's pretty wild. So you've got these smaller satellites that are opening things up, but then you have these massive ones
Yeah.
that are just pushing the limits of what's possible.
So it's the best of both worlds.
Exactly. You need both.
Yeah.
Like, you've got companies like Planet, Capella Space. They started with smaller satellites. Now they're building these massive platforms. More sensors, more data, all the time.
So much is happening so fast. We've gone from looking through telescopes to this amazing array of satellites. It's mind-blowing.
It is incredible.
But let's talk about the reason we're doing all of this. Climate change.
Yeah.
We have all this data, all this stuff. How are we actually using it to understand and deal with climate change?
That's the million-dollar question. And that's exactly what we're going to talk about next.
Awesome. But before we get ahead of ourselves and jump into the world of AI and climate models, let's take a second to think about why this even matters.
Good idea.
We're not just looking at the effects of climate change, but trying to really get it, to understand it, and hopefully figure out how to fix it.
It all comes down to using technology to protect our planet.
Exactly. And one of the coolest things happening right now is using AI to create these really complex climate models. Okay, AI-powered climate models. This sounds really interesting, but also complicated. What are we even talking about here?
I know, right? So there are a couple of main approaches, and they're both powered by machine learning. The first is what we call climate ML-based models.
Climate ML-based models. Got it. And what do those do?
So instead of just relying on these super complicated physics equations, which can take, like, forever to process,
Yeah.
these models use machine learning to look for patterns in massive amounts of data.
Okay.
Basically, they're learning these shortcuts so they can make predictions way, way faster,
How much faster are we talking?
to 1,000 times faster in some cases.
1,000 times. That's amazing. It's incredible. And the best part, they're often even more accurate, especially when you're looking at specific areas.
So faster and more accurate. That's what we like to hear. It's about working smarter, not harder, right?
Yes,
Sam?
got it.
Now, you mentioned a second type of model. You said geospatial AI foundational models, right?
Yeah, those are the big brains of climate modeling. We're talking about models that have been trained on just insane amounts of data, everything from satellite images to weather patterns to historical climate data.
So they're like the supercomputers of climate modeling.
That's a good way to put it. It's like having a team of the smartest climate scientists working 24/7 going through all this information.
Okay, that makes sense. Give me an example. How are these models actually helping us with climate change? So there's this model called Aurora. It's developed by Microsoft, and it can actually predict global air pollution levels.
Seriously?
Yeah, and it looks at 6 major pollutants, and it can look up to 5 days in advance.
5 days? That's incredible.
Get this, it does all that in under a minute.
A minute? I can't even choose what to eat for breakfast in a minute.
It's mind-blowing. And the thing is, this kind of speed and accuracy, it just wasn't possible with the old ways of doing things.
Okay, so we're talking about some serious power. But who has access to these tools? Is it just these big institutions, you know, with the supercomputers and stuff?
That's a great question. And the good news is things are changing. There's a real push towards open sourcing a lot of this AI tech.
Open source, you mean anyone can use it?
Exactly. One awesome example is this collaboration between NASA and IBM. They've created this open source platform called Prithvi.
Prithvi, cool name.
Right. They actually designed it initially to map floods and burn scars from fires.
Okay.
But it can do way more than that. We're talking tracking deforestation, predicting how well crops will grow, even keeping an eye on greenhouse gases. And get this, Prithvi, it can actually make climate models 12 times more detailed.
12 times. And it's all thanks to AI.
AI is a game changer, that's for sure.
So we're not just using AI to study problems, but to find solutions, too. This is really exciting stuff.
Absolutely. And this is just the beginning, you know. One of the most promising things on the horizon, I think, is the development of digital twins.
Digital twins. Okay, now we're talking sci-fi. So, like, a virtual copy of Earth.
You got it. Think about it. We could have a digital twin that shows us exactly how our planet works in amazing detail. And then we can run all kinds of simulations, you know. We could see how rising sea levels might affect coastlines or how different weather patterns could impact wildfires.
It's like a giant simulation to help us save the planet.
Exactly. And the best part, these simulations, they're not just happening in some lab somewhere. There are some huge projects happening all over the world. Like the European Commission, they're building a digital twin called Destination Earth, or DESTIN for short. And their goal is to create a super high-fidelity replica of Earth so they can predict environmental changes in really fine detail.
Wow, that's incredible. So with Destin, we could actually see what would happen if, say, a hurricane hit a certain area or if a volcano erupted.
Exactly. And the really exciting thing is the collaboration aspect. They're making Destin an open platform so scientists from everywhere can use it, share data, and work together to find solutions. Climate change is a global issue, right?
Right.
So we need a global response. And this kind of technology is making that possible.
Collaboration is key. I love it. We've talked about all these big organizations doing amazing work, but earlier you were saying it's important to democratize this information. What does that look like? How do we get everyone involved?
It's about making this information easy to understand and useful for everyone, not just scientists. And there are some really cool things happening.
Like what?
Imagine being able to experience climate data firsthand through virtual reality.
Oh, that's cool.
Right. And there are actually platforms doing just that. Like MIT Media Lab, they've got this platform called EMC, and it lets you explore all this climate data in a really interactive way. It's like you're actually inside the data.
That sounds way more engaging than just reading a report.
Definitely. But if VR isn't really your thing, there are other ways. We've got these things called data cubes.
Data cubes.
They're like these giant libraries for Earth observation data. They take all this information and make it easy to search and understand.
So no more digging through endless spreadsheets.
Exactly. One really great example is Digital Earth Africa, or DE Africa. They use these data cubes to keep track of water across the entire African continent.
The whole continent.
The whole continent. They have this service called the Water Bodies Monitoring Service, and it keeps track of over 700,000 bodies of water every week.
Wow. We've covered a lot of ground today. We've gone from these like massive satellites to one smaller than a shoebox. We've talked about AI that can predict air pollution, and we've even touched on creating digital twins of our planet.
And we're just scratching the surface.
Exactly. And the most exciting thing is, this is just the beginning. Who knows what incredible breakthroughs are just around the corner? So, to everyone listening, stay curious, stay engaged, and let's all do our part to protect this incredible planet we call home.
Couldn't have said it better myself.
Thanks for joining us, and until next time, keep looking up.